Welcome, video example 10, unit 2, chemistry 1B. We're going to determine the effect of temperature on spontaneity. So we have to calculate delta G at two different temperatures for the Haber process given the information that is at the bottom of the screen. Essentially what we have to do is calculate delta G using the Gibbs free energy equation here. So we plug the values in. This is the delta H value here. The temperature in Kelvin, the delta S value here, but remember we need to convert, very important, to kilojoules so that the units of joules cancel and we're left with units of kilojoules. Okay, so we see that the delta G value works out to be minus 33.3 kilojoules at 25 degrees, and therefore the reaction is spontaneous. Now let's go to 500 degrees. So remember that the temperature now has to change, so we need to convert it to Kelvin temperature over here. Same approach, plugging the information in. So this is the delta H value. This is now the new temperature value, and we have the delta S over here, but again we have to convert to kilojoules to get rid of the units here, and of course the Kelvin units are going to cancel to give us consistent units in kilojoules. And when we calculate now the delta G, we end up with a value of 61 kilojoules. So you'll see now at 500 degrees C this reaction is not spontaneous. Right? So does this answer make sense? Let's check this. Okay, so both delta H and delta S are negative. And here this is where we see the temperature dependence. At low temperature, the delta G is going to be negative and spontaneous. Okay, and at high temperature, the T delta S is going to be a large positive number, and so therefore that means that delta G is going to become more positive, and thus essentially at a high enough temperature, the whole reaction will become non-spontaneous. You need to go back to those slides which show the relationship where we change delta H and delta S in terms of sign, positive and negative sign, and what happens to the value of delta G to understand what I've said here.